I'm here to present our company, Forsler Schwabe, but it will just be a very short presentation of Forsler Schwabe and the cooperation with Rönning, and also our way of seeing how to work with the LED and also with light management systems. That's the main focus with this meeting. There will be some slides with some different products, but I will not focus on them especially. It will be on the technique with LED and also on the light management handling. Just start with some short slide that we actually were founded, Forsler Schwabe was founded in 1919. So we are, sorry to say, but we are a bit older than Rönning, actually. So some of the product ranges that we are working with, and also that Rönning is actually storing here in the warehouse here. Some of the LED technology, OLED is something that we work with, organic LED. Lighting components. Lighting components is something that you hopefully will purchase from Rönning here in regarding of quite a lot of spare parts, actually, in different fields, both in electronic and conventional ballast and so on. We also work with the lighting control system and also with some different lamps. And different lamps has, of course, come up now since we have been working more and more with LED in the LED field. Different application fields where the lighting is needed. I don't think that we should get too deep on this one. Just want to tell you about our brand journey. In 1990, we started with lamp holders, the beginning of the last century. And one key issue that is could be of quite important is that 1979 we started with the production of LED. So LED started really early. In 2002, we were bought by a company called Masashita. Masashita, and more famous brand is Panasonic. So we are since now 11 years owned by the Japanese company Panasonic, and we belong to their group in the lighting division. What we can see over, if we see Forsler Schwabe as a company compared to our colleagues in the business, is that of course the resources is shifting over to the LED technology. That is what everyone thinks is the main focus. So we are leaving a lot of other technologies behind and focusing on LED and what that can bring to us. This is where we are situated today. In Asia, it's Panasonic brand that we're working with. In Europe, we're working with Forsler Schwabe name. And in US, we're working with Universal Technology. So it's sort of divided into 3 different parts in the world. Also, we have a lot of distributors around the world, especially we have some in Europe and a lot of distributors in Russia, Middle East. What we don't have is an official distributor there. But we would like to put a flag there as well. And me and Gunnar have been talking a lot about this, to closing a deal now to make Rönning an official supplier, official distributor of Forsler Schwabe and the Panasonic Group. And we hope to do that very soon, in a short time. Different production sites, mainly in Germany and Serbia. Of course, environmental and quality management is very important to a company like us, especially when we now belong to the Panasonic Group. They have something that they call the clean factory. And the clean factory is quite difficult to get a certificate of that, but I will not go into details about that. Just to explain that we are trying to do our share of the environmental thing here on Earth, actually, as much as we can. Our product range is, you can see the biggest one, the 60, with over 30% is actually magnetic ballast, old conventional drivers. And you can say that, okay, this company will not last for long. if it looks like that. I will explain later on why the share is so big now. It can be that we have been one of the world's largest producer of conventional ballast for many, many years. The electronic ballast are, of course, a big issue here as well, and also the LED. It's a very strong field, and also lamp holders. I will come back to the conventional ballast and the magnetic ballast, why this figure is quite important for us here. Research and development. Of course, the development and research are focusing on LED, on the LED field. Everything else is almost turned down, because the LED field is the one that we actually are focusing on. And you can see in our different sites here in Germany, we have down in Urbach, in Camp Lindfort, that is our LED center. Also, the people in Lüdenscheid that actually are working with lamp holders are now working with LED. We also would like to see our customers as we are one-stop shop, that we have actually everything that includes alumina. We also have we're also working with our 5-year warranty, 5-year product warranty as well. Now over to some of the what we talk about today, something about the LED and something about the basics of LED. This will just be some basics. We'll go over to light management after that. The first LED was actually produced in 1907. That was the first one, but it was not commercialized until the early 60s. And when it then came up with, when we worked together with the red and green light, because the first one was the blue light that came. Then when the red and green light came as well, we were also able to produce the white light. And the white light is what we're aiming for today, when we are going to replace all the light we have today with LED light instead. So in order to get it working, we need all these 3 lights in order to produce white light. And when you produce the light, you of course will have different opinions at your customers. What is the right light? What is the right temperature? And here you can see a sort of a scale. It's working with a Kelvin scale from 2,700 Kelvin up to 7,000 Kelvin. And when do you need to use the right color temperature of the luminaire? That is, of course, up to the customer, what they are used to, and what you can explain to them is that maybe if you go down to 2007, it's a very warm color. It looks like this color with the halogen here, with the halogen light. We go up to 7,000 Kelvin. You have a very, very bright light, very bright. So it's a wide range of the color temperature that you have to take care of together with your customers as well. It's a lot to think about, but this is probably the easiest one to think about when you're working with LED. Also the color, not only warm and cold color, you have all the color shifts as well, all the spectrum in the same color that are measured. And normally you measure it in what you call CRI, the color rendering index. And to have it, the higher you have it, the more up to 100, the more it looks like the natural light, the sunlight on the outside. That is, of course, what everyone would like to have, but it's also more and more expensive to produce LEDs that are up to this level. So, for instance, if you are having an office lighting, the CRI could be somewhere between 80 and up to 90. That's okay for the office lighting. But if you're going to a shop and you're going to see the color shifts in clothes and so on, then you need a higher color rendering index, and you need to be over 90, up to 90 and over that. There is also, you can see that we have a food LED as well, and that is also all the different coloring rendering indexes. So if you would like to light up some food in a grocery store, meat for instance, to have it very reddish, then you use a special CRI for this. So you can really get the right light for the right product as well. This is what we as a manufacturer need to think about. What is the customer need actually? We think about a lot of things, but maybe half of the things that we think about, it will not be used outside, you know. Over to something that we call the lifetime. And I think this, when I talked to Gunnar, he said that this is an ongoing discussion about the lifetime of the LED here on Iceland. And I think Iceland is not the only place that they talk about lifetime here. Because the problem is today that we don't have a real standard to compare. So we're using different standards, but this is one standard we're using. And it says expected lifetime. And it is expected because we have not, of course, we have not been able to control if the fact is that they can run for 50,000 hours or 70,000 hours because we don't have, we have not had a product for so long time. So everything what is explained here from us as a producer or a manufacturer is everything is theoretically calculated from a basis test. So, for instance, if we have an L90 F10, that's quite common. We always present our product with this one. If it's the right one or the wrong one, I'm not sure about that, but this is one way of doing it anyway. And then you have the L90. It says of the 50,000 hours, you have 90% light output left from the beginning, from when you started. That's of the 50,000 hours. And F10 is a failure rate of 10% of the LEDs will go down after 50,000 hours. Everything is, of course, theoretically, and this is measured in an ambient temperature of 25 degrees. If the temperature goes up, well, then of course the lifetime will go down, and it will go down rather rapidly here, as well as you can see on the curve here. So this is really a challenge for us as a manufacturer, together with all our colleagues around the world that are producing LEDs, just to have the right way of measuring so you can compare what you're actually purchasing or what you're buying.
Margir eru nota en þó ekki allir og það byggir á því að þessi 90 af upphaflegu ljósmagni ákveða þá að hún þoli 50 formið á kúrfuna sem við notum. Þeir vilja meina það að það fyrir 12-15 þess að geta búið til að 10% þarna 10%.
If you have any questions, please just let them out in the air. See if I can answer them. One thing that more is absolutely one of the basic things is the what we call the binnings. And the binning is how you produce the LEDs, how narrow you can be with the colors. You can have big binnings or small binnings, but it all depends on how much you're willing to pay actually, because we can do it very, very narrow, and but it will be much more expensive. I'm not sure that the customers would like to pay so much. And actually, I don't think that we need to adjust the binnings to the purpose of the luminaire as well, because sometimes you don't need a narrow binning. You can easily live with a wide binning. Normally, when we produce our products, we use the what we call the three-step macadams. And this is what we guarantee in some of our LED module ranges. A three-step macadam for the lifetime of 50,000 hours. After 50,000 hours, it can go down to a five-step macadam. So it can shift after 50,000 hours. But still, this is also a theoretically calculation that we are making. So we're not really sure. So of course, you can ask you the question if you can guarantee 50,000 hours, but you have only 5 years warranty. So, okay, you came to me after 10 years and say that they have only burned for 45,000 hours. Yeah, okay, but you don't have any warranty left. But that's the problem we have with everything. So, but this is about the bindings anyway. And that is something that all the big manufacturers of LED, for instance, Cree in USA, Nichia in Japan, are working with. And this is the difficult way. It's very difficult to get them very narrow. You can sort it out by hand, but it's very expensive to do it as well. But if you're willing to pay for it, then you will have a very narrow binding as well. We talked about the difficulty of getting standards, and it's still very difficult to get the standards on the LED because, I mean, if we as a supplier and manufacturer are a bit confused about this world, I can imagine how you feel and how your customers feel about this. If no one can tell us what is the standard of the LEDs. But they're working on it, and they are getting closer to find a solution for these standards as well. One is the European Saga Consortium. It's a cooperation of independent companies here in Europe that are trying to find one type of solution with these standards. For instance, it could be for these LED modules. Here's different manufacturers here, and this is our module here. What it said here was that for the standard, it should be okay with two holes to get it fastened with the heating element here. But we said, no, it's not enough for Vossloh-Schwab or for Panasonic. We would like to have 3 holes. So to keep the Saga standard, we need to do our own 3 holes and also the Saga 2 holes. So we have 5 holes instead. So this is what can happen with the standard. The standard is also how the different modules should look like and how they should act as well. So the standard is hopefully for all of us, it's much better to have this standard, even for us as a manufacturer. We don't want to go alone in this, you know. But there are many big manufacturers that are really working with this Saga group as well. All the big suppliers here in Europe are doing it. And of course, I know that you are not in the European Union, but you also follow the rules according to this. This is one type of LED modules that we produce here, and from 2,000 lumen up to 5,000 lumens. This is a shop module. What I would like to show here is actually that the lumen per watt is increasing every year. So every year you get more lumen output per wattage. And it's increasing very rapidly, actually. What I can show you is also a linear version. A linear version that is mainly could be for replacement for T5 or T8 tubes in a complete new luminaire. Here you can also measure it, and you can see the lumen output. I think this is more interesting for you to see what the lumen output is on the linear one when you're going to replace something that you really know what the lumen output is. We're doing the same thing also with street lighting and high bay lighting engines. We're using, on this one, we are using lenses just to project the light. On this one, we're using reflectors. There's 2 different types of way of handling the LED from a high bay. And lenses you can use even on the smaller output as well. We have here industrial Luga, industrial, as we call it, up to 10,000 lumen, what we have today. The difficult with this one is to cool it down. Because it's, if you use this one, maybe if you don't want to have a fan inside it, a rotating fan that cools it, maybe you have a cooling that is big like this. So, but we will try to find a solution on this one as well. Something more about the LEDs. This is mainly replacements for halogen lights. I'm not going any further with this one. Just want to show you that there is also some other products that you can use 230 volt directly inside to these products. The driver is inside here. Some of the downlights mainly replacing for just for this one maybe for 2 by 13 watt downlight compact fluorescent light. And there is a whole new series that is coming. You can see some of the modules at the table over there later on. This is a typical replacement 5 watt 5 watt LED is a replacement for a 50 watt halogen light. And I think the halogen field is the easiest way to actually to replace. This is a nice picture. This is some of our drivers. The driver side is one of our largest areas actually. This is just to show how difficult it is to produce drivers, because you need to fulfill a lot of requirements, and not only drivers to ourselves, but of course to our competitors, because we would like to adjust. If you buy something from Philips or from Osram, you can of course use our driver instead. So, but there is a lot of drivers that is produced. And for every new board that is produced, we also produce a new driver. Also on the office line and on the street lighting line here as well. This now we are over to magnetic news. How can it be news with magnetic ballast? Yeah. Okay. There has been a discussion about magnetic ballast, conventional ballast, that in 2017 everything will be banned. You're not able to use them anymore. Have you heard about that? Mm-hmm. Yeah. Is it true? No. Everything you hear is true, yes? No, it's not true. It's not about banning products, actually. It's about setting up a new requirements for the energy savings. So no matter what kind of product you're using, as long as they fulfill the requirements, you can use the product. So you can still use magnetic products as long as they fulfill the requirements of the 2017. So that's why the big issue was for us to, because when we first heard about this, of course we needed to see, should we completely lay off the conventional ballast production or not? Then we digged a bit deeper in this. And of course, the need for conventional ballast is still very high out there. And we can see on our sales that our sales on magnetic ballast is not dropping. It's like this. And as long as it is like this, and we have a production that is quite lean, then we will keep on producing it. But of course, we need to fulfill the requirements on the ballast. And I have a brochure over there about that is describing the whole problem actually. But the main thing is that the consequence is that it will be possible to buy and manufacture luminaires and exchange luminaires after 2007 with ballast. The only problem is that we can't fulfill it below 30 watt. Because lower than 30 watt, it's not possible to fulfill the requirements. But for everything over that, it's okay. But it needs to be labeled on a special way. They need to be labeled as A2, A2 BAT. BAT stands for Best Available Technology, and A1 BAT. A1 BAT is only for dimmable ballast. So these are the only ones that is allowed after 2017. But everything is always what we do in our catalog. Gunnar can show you in our catalog that we have this label on every product. So just to be sure that you are choosing the right product when you're changing anything. So maybe this has been straightened out, some things anyway, about the conventional and magnetic ballast, that they will still exist after 2017. Otherwise, we'll be out of business. Some light management. We spoke about this earlier on here, that of course you can change everything to LED, and everything is happy and everything is fine, and you will save maybe some euro cent. But to make the big savings, you actually need to work with light management, both indoor and outdoor, because there is where the big savings are. Just want to show you a little film. Gonna works. This is some of the basics what we are working with the light management. We're working in 3 different areas with the outdoor system. Actually, one is completely remote, and you will also have the feedback from the luminaires and from the field what you're working with after installation. So you can always make a diagnostic of the area that you have installed these outdoor system. You can also have something that we call the flex night. Yeah, you can control them remote out on each local, but you will not have any feedback. And there is also one you can work with that is just local. You just produce it on each pole. But all these 3 can work in the same way, but there's a different way of handling the light management. This is just an example, just to see what is happening out in Europe here. 35 billion kilowatt hours per year for Europe's street light. It's only the street light. It's up to 40% of the total energy consumption here. If you can save 50% of this, you can shut down 2 nuclear plants. You don't have any problem with the nuclear plants here. but we have in Europe. So this is just a figure to show it. There's also a different way of course, how you can dim it. You can switch on and off with according to brightness, and ramp it up and down. And all this will, of course, be much easier when you have an LED solution to work with, because then the light goes on and off very quickly as well. One other thing that can be quite useful when you're having the main things with this control system is when you put up an aluminum outside, you always over-specified it, because you know over the lifetime it will decrease. The light output will decrease. Here you can, you don't need to do that, because you just dim it up, and then you have an automatic dim curve on the light management system, so you can have the same luminance without over-specifying them. Just something that are in our portfolio. This picture could be quite interesting, because it could be, I think you all passed the car downstairs here. And Rönning is now setting up and also selling these kind of solutions. This is also one kind of solution that actually is already outside here. We have it on each pole. We actually have electricity on each pole. And this is we are working on a solution with this, actually, but I don't have so much more information about it now, but could be a good solution to have a thing like this as well. Maybe we will see it, you can buy it from Rönning later on here. So. The indoor system, over to the indoor system, also a little movie with the same nice music. So. Our system is called a LIX system, and this is one of the main features that we're working with. We're working without a laptop. You don't need a laptop in order to install the system. Wireless technology with an ocean technology. I will explain it a bit later. The DALI system is what we're working with, the DALI standard. I think that you're very familiar with that here on Iceland, actually, because you are really good at building with DALI system here, even in private homes. Easy plug-in quick configuration. Applications is, of course, the offices, industrial buildings, schools, and so on. Even in private homes, it could be quite useful. This is some of the components that we are working with. I will go just shortly through them. This is the light controller. Everything works with this rotary switch here that we have here. So you don't need to have any computer to make the installation. If you can make it as an installer, you will make it by yourself. So it's quite easy, not for a complete 15 buildings flat, but for maybe for one office, maybe for 1 or 2 offices, because you can connect up to 64 dolly operating ballast operating devices into 16 groups on this one. That you can also do with this one. This one is even a more simple one, that you control it with the small dip switches on this light controller. Also up to 64 operating devices. The smallest one, there you can control 3 dolly devices together with this one. We talked about wireless system. We also work with wireless control buttons, off and on, and also remote controls. And everything works with this, what we call the an-ocean technology. An-ocean technology is when you push the button, you create the energy for the signal to get to the from the transmitter to the receiver. So you don't need to have any batteries. You can put them anywhere you like, and you don't have to worry about the battery standard. Also, one thing that has been quite difficult to produce is also for sensors for high bay. Here we've got 2 different sensors for that. Indoor controls, how to save. This is just also a calculation again about the consumption of energy. We know that energy, the light energy, is 14% of the total consumption. Just to save 50% of that could actually close 19 nuclear plants. Just an example how it can work. Well, we know the actual situation. The light goes on when you get into the building, right into the office. The morning light comes in, but the light is still on, and you are not using it. The solution is, of course, to use multi-sensors with the presence and brightness sensors. Also the light controller and the dimmable luminaires. The result is, of course, that everything will work automatically during the day. And to save significant over 50%, it's very easy to do in that way. Also the same in warehouses, of course. This is just something, I know that you're working with dolly. 1 to 10 volt is not very common up here, I think. It's common in private homes and so on. But the dolly system is, of course, the most flexible system to work with. This is just one reference example. It's from Spain. We started with magnetic ballast with 2 times 26 watt ballast. The total consumption was 1,106 kilowatt. We changed into 46 watt LEDs. And the savings for this building, solely for this building, was 33%. But when we also added the sensors, the savings was even up to 49%. Huben warehouse in Cologne in Germany. It's our main distributor in Germany. We started here with this magnetic ballast 58 watt, and they have a total consumption of 4,100. And we changed into T5 instead, not to LED, just to T5. And then we made a savings of 30% of this installation, because it was already old, it needed to change, but then we put in the light controller as well. And then we changed it to 30% and also added the sensors to save even 27% more. So this is just two examples how much you can save for a customer just to change this. And for you, it's perfect to sell these luminaires from Torn and buy them from Gunnar here, the light controller here, and just make the installation. So that was all for me. So if you have any questions, I will still be here, and if you have anything now or otherwise, thank you.